$34. Another 1 ticket for a student without ASB, 6 for students with ASB, for a total of $38. Find the price of tickets for students with and without ASB cards. Okay, so we got to assign variables. There isn't really a good variable, so I'd probably just use X and Y. So I'm going to call X without ASB and Y with ASB. Okay. All right. So basically we're going to write a customer 1, customer 2 equation, right? So how many without ASB for the first customer? 3. So 3x plus how many with ASB? 2y. And equal to how? I did not write 2y, did I? How much money did that person spend? 34. And then the second customer was how many without ASB? 1 without ASB, and how many with ASB? 6 with ASB, and spent a total of what? 38. All right, substitution, elimination, or Kramer's rule? You want to use substitution? Okay, so we're going to take this and solve it, move it to the other side. How do I move that to the other side? Subtract it. Okay. Do I have to use substitution? No, you can use whatever you want. Now I'm taking this and I am plugging it into X in this other equation. So I've got 3 plus 2y equals 34, and I'm going to substitute in negative 6y plus 38. What are we going to do with this 3? Distribute it. So negative 18y plus, you guys got to help me with the arithmetic, what's 3 times 38? You all have calculators. 114 plus 2y equals 34. All right, what's negative 18 and positive 2? Good. And at the same time, take this 114 and move it to the other side by subtracting. What do you end up with? Good. And then we're going to divide by negative 16. So what do you end up with? 5. So we have got 5 with ASB. Okay. Or no, $5 for the ASB card, right? And then I've got to I'd probably go ahead and just plug into this one here to get how much the non-ASB ticket was. So negative 6 times 5 plus 38. What's negative 6 times 5? 30. Plus 38 is 8. So we would say that it is $8 without ASB and $5 with ASB. With ASB, you get in free. Yeah. This was a good, it's a made-up problem, right? I had to come up with a scenario. That's the best one I could probably come up with at the time. All right. I don't know. All right, let's look at 2. So a winning softball team orders a combination. Think about a combination of 19 ice cream treats. Ice cream sundaes cost $5 each. Milkshakes cost $4 each. The coach paid a total of $84 for the frozen treats. How many of each type did the team order? So I would probably use S for sundaes and M for milkshakes, right? All right, so I'd probably write a money equation and a total equation. So my money equation, how much is a sundae? $5. So 5 times the sundae plus how much is a milkshake? $4. 4 times the milkshake equals a total of how much spent? $84. All right, and then we need a combination. It says there was a combination or a total of 19 ordered. So wouldn't I take the sundaes plus the milkshakes and set it equal to 19? Yes. All right, substitution, elimination, Kramer's rule. Elimination. Okay, so what do we want to eliminate, the S or the M? S. Okay, so I'm going to multiply by negative 5. So I'm just going to rewrite this one. I probably should have planned that better. So negative 5s minus 5m equals, what's negative 5 times 19? Negative 95. All right. The s's go away. What's 4m and negative 5m? Negative 1m. 84 and negative 95 is negative 8. And then, is it 8 or 11? 11. Sorry. Looking at the wrong answer. All right. Oh, highlighter. That's not good. All right. And then we divide by the negative and we end up with 11 milkshakes. All right. To get Sundays, I'd probably plug into this one here, right? Yeah. So Sundays plus 11 equals 19. So how many Sundays? 8. So we would write that there are 8 Sundays and 11 milkshakes. It's really coming down. Or is that Thunder, or was that the guy with the... That was Thunder? Okay. Sometimes it sounds like the guy rolling by with the trash can. All right. All right. We knew 0 period, the ground wasn't shaking, so it wasn't an earthquake. So, all right. When I was growing up, I lived where there were a lot of earthquakes, especially at that time, but it was a military base, so they built bombs there, so you could tell by the sound if it was an earthquake or a bomb. Yeah. Yeah. Okay. So, we are looking at solve the system. It says you have to use substitution. So here's the deal with this, okay? There were three main methods we used, right? Substitution, elimination, and Cramer's rule. If it is not multiple choice, so it's an open-ended or free response type of question, and it tells you to use a method, you must use that method. Or even if you get it right, you will not get points for the problem. Does that make sense? Because even if it scores you correct for the problem, I'm going to go back in and look and make sure you did it the right way. Okay? So you need to know your 3 methods. However, if it's multiple choice and it says to use substitution and you use elimination, I'm not going to go check the multiple choice. Does that make sense? All right. So if all else fails, use the method that it says. Okay? But you can always check it with another method or check it by plugging your answer back in. Okay, so you should get 100. There's no reason to not get 100% on this one. All right, we got to use substitution. So do you want to substitute? Do we want to solve for x or for y? X. Okay, so I'm going to move the y to the other side. How do we do that? Add it. Okay, so I'm basically, every time I see an x, I'm going to plug in a y. So I've got 2y minus 3y equals 3. What's 2y minus 3y? Negative y, so y ends up equaling negative 3, which means that x ends up equaling -3. You cannot leave your answer like that. Remember, you have to do this. To type in your answers, I would say use parentheses and no spaces. Okay? That'll do the auto grade a little bit quicker for us. All right. We good with substitution? All right. Elimination. So, I know it's not lined up pretty, but do you want to eliminate the x or the y? The y. The y. Oh, it's already set up perfectly for that, isn't it? Yeah. X plus 2y. What if it's not set up perfectly?
Then you multiply the whole thing.
Yeah, you multiplied the whole thing by something, right? So what's 3x plus x? 4x. 4x. The y's are gone. What's 7 plus 5? 12. X equals what? 3. Do you want to substitute into the 3x equation or the x equation? X equation. All right, so 3 plus 2y equals 7. 2y equals? 4. Good. Y equals 2. And then rewrite your answer, 3, 2. All right, we good with 5? Okay. 6. It says we have to use Cramer's rule. I would make sure that this is written, and it might be written nicer on the test. I don't know. I haven't looked yet. Nice and lined up like that. Okay? Yep. So the first thing we're going to look at is our denominator, because if the denominator doesn't work, then the whole thing doesn't work, right? Yep. Denominator cannot be equal to 0. So what is your x column?
2 and
Good. What is your y column? Good. And you know what? Even before I do the other part, let's go ahead and calculate that and make sure it's not 0. So what's 2 times 4?
8.
8 minus 1 times negative 2. So what's your denominator equal to? 10. And I'm going to write that. So I know I can keep going, right? All right, so let's solve for x. What gets shoved upstairs?
The
Good. And what goes in the x column?
your answer.
Good. And then over here, I'm solving for y. What gets shoved upstairs? And what goes in the y column? Good. We're going to multiply. So what is 3 times 4? Minus negative 1 times negative 2? 2. So 12 minus 2 is 10. And x equals 1. All right. 2 times negative 1 is?
-2.
Negative 2 minus what? 3. So we end up with negative what? 5 over 10, which is?
-1/2.
So you have 1, negative 1/2. And remember, it might just ask you to solve for one variable or another. I think we have one like that here, actually, in the next problem. And Kramer's rule is a really good way to do that, okay, if you just have one variable.
So when you're solving for x, you shove the y values up.
You shove the opposite, whatever you're solving for, shove the opposite upstairs, put the answers in for what you're solving for, okay? All right, number 7. It says use Kramer's rule to solve for x, okay, which is the good method to being able to do that. So all I care about is the x column, the x. I don't care about the y at all. I'm not even going to write the y out. What's going in for my answers?
9, 5.
9, 5, and for the y's?
-7, -3.
Negative 3. Okay. I'm solving for x. What would get shoved upstairs?
-7, -3.
And what goes in for the x's?
3, 5.
3, 5. All right. Looking at the denominator first to make sure I can keep going. 9 times negative 3 is?
-21,
Good. Minus, what's 5 times negative 7?
35,
Double negative is?
positive.
Positive. So what's your denominator?
62. Oh, no, never mind.
8?
Oh,
All right. 3 times negative 3 is?
I didn't think it was right.
Okay, minus 5 times negative 7.
You don't think it's 6.
Okay, negative 9 times 30, or negative 9 plus 35 is? 26. Reduce it, we get?
Oh, that's good.
13 over 4? All right. We got to get this finished before the power goes out, right?
I know, right?
Make sure we get it recorded before the power goes out.
Please hurry up.
Okay. So here's what's going to happen with these two questions. One of them is going to ask about the consistent, independent, consistent, dependent, inconsistent. One is going to ask about the number of solutions. Okay, so it's not going to be like that with these choices. Okay, so you need to understand both answers. All right, when you see these, you want to solve for y. Okay, that's the best way to go with them. So I'm going to get these to get y by itself. I'm going to move this 3x over. How do we do that? Subtract it. So negative 5y equals negative 3x plus 7. I'm going to divide by the negative 5. So negative 3 divided by negative 5x plus 7 divided by negative 5. So there's one of my answers. I really don't need to do anything besides that. I'm going to move this over. How do we move the 2x over? Subtract it. So now, are the slopes the same?
No.
Are the y-intercepts the same? No, so which one does this one have to be? It's consistent and independent, and when it's consistent and independent, remember it crosses, so it has exactly one solution. Because again, it might say the consistent and independent, it might say one solution. All right, so you have to understand both. All right, there's a chart in your notes that you probably need to go study tonight. So this one right here, classifying again, I'm going to get y by itself. So what do I do with this negative 7 to move it? Add it. So we've got equals 7x minus 4, and then what do I do with the 6? Divide. So 7, 6x minus 4, 6. I don't really care about reducing it too much. Well, maybe. Let's reduce it, see what happens. 7, 6x equal, or minus what? 2 over 3. All right, now I'm going to take the 14 and move it. How do we move the 14? Subtract it, so negative 14x plus 8, divide by negative 12, x 8 divided by negative 12. So y equals, what does negative 14 over negative 12 reduce to?
7 over 6.
And 8 over 12 reduces to?
4 over 3.
4 over 3, are we sure?
2 over 3.
How about 2 over 3? What do you notice about the equations?
They have like the same
They're exactly the same. Which one of these is this if it's exactly the same? No. Consistent and dependent.
Yeah, come on.
With infinite solutions. Because, right, I could put anything in for x and it would always work. Okay? Inconsistent with no solutions is where you end up with parallel lines, which means they have the same slope but different y-intercepts. Okay? All right, number 10. You ready? All right, we're supposed to use back substitution. Even if it didn't say use back substitution, you can see that we have a z, and we're going to plug that in, right? So plug that into that one. You end up with negative y plus negative 2 equals negative 5. What do I do with the 2? Add it. We get negative 5 plus 2 is negative 3, and then divide by a negative 1, right? And now can't I substitute into this one? So we've got x minus 4, what's going in for y? 3 plus 3, what's going in for z? Equals negative 14. Negative 4 times 3? And 3 times negative 2? Negative 12 and negative 6?
Negative 18.
Equals negative 14. So what's x equal to?
4.
4. So you know that you got 4, 3, negative 2.
What's back substitution?
That's where you start from the back and you keep substituting in, right? Basically, use common sense on that one, right? They gave you z, solve for y. Once you get y, plug in x and z, or plug in z and y. Okay? All right. Solve the system of linear equations. It says to solve only for z. So I probably want to try to, when I'm lining these things up and I probably want to keep z in. Okay? That would be the quickest way. Notice, am I having to solve for all three?
Nope.
No, just one variable. All right, so let's see. Let's try to eliminate x first. Okay? So if I take and I use this one as the multiplier, in order to add to this one, if I'm going to get rid of x, what do I need to use for the multiplier? 2. So I've got negative 2x plus 2y plus 4z equals 2. All right, the x's are gone. What's 3y plus 2y?
5y.
What's z plus 4z?
5z.
And then 0, right?
7.
Okay, now I'm going to use the other one. I'm going to multiply with the other one. So instead of 2, what are we going to use to multiply? 5, right? Because I want to eliminate the x on this one. So I've got negative 5x plus 5y plus 5z equals 5. The x's are gone. What's 4y plus 5y?
9y.
2z plus 5z
7z.
equals
9.
9. Okay. Now, unfortunately, I'm going to have to multiply both of them, aren't I?
Yeah.
So, and what's wrong?
Isn't it 10z since it's 2z times 5?
2z times 5 is 10z. That's right. That's a typo. So, what is 2z plus 10z? 12z. Right?
Wait, 10.
I had a boo-boo right here, right?
Oh, sure, yeah.
It was 2 times 5. I just did the 5. I don't know what I was doing. Okay. All right. It happens.
It's okay.
Okay. So now I need to multiply both of them by something. We want to keep the z, right? Because we're supposed to be solving for z. So I want to eliminate the y. What am I going to have to multiply the first one by? 9. So we end up with 45y plus what? 45z still equals 0. What do I have to multiply the second one by then? Negative 5. So I'm seeing negative 45y minus what? 60z equals negative 45. All right, the y's are gone. What's 45 and negative 60?
Negative 25.
I think it's 15, isn't it? All right, minus 45. All right, so z is equal to what?
Negative
positive 3. Do I have to do anything else? It doesn't ask me to go any further than that. Okay? All right, one more system of 3 it looks like. So it looks like you got to make sure you can do 3 of these things. It says solve the system of linear inequalities, so I have to go all the way this time. I've already got one that's down to x and z, so if I could eliminate y on this one, that would be great. Am I able to do that without doing any work?
Yep.
Yeah, so all I'm going to do is rewrite them to line them up. Plus z equals 2, 2x plus 2y minus 3z equals negative 4. All right. X plus 2x is? 3x. Z minus 3z is?
Negative 2z.
Equals negative 2. All right. Looking at what I have left here, I could probably eliminate the z. What would I get? What would I have to multiply this one by? Okay, so I have 10x plus 2z equals what? Good. What's 3x plus 10x?
13x.
Z's are gone. What's negative 2 and positive 2? 0. So what's x? 0. All right, probably the best thing to do for z is to plug into that one there, right?
Yeah.
So 5 times 0 plus z equals 1, so z equals 1. I still haven't gotten the y, have I? So do you want to go into the first one, the second one? First one. Okay, so 0 in for x, minus 2y plus 1 equals 2. So that's gone, right? What am I going to do to move the 1?
Subtract.
And what do you get? 1. And then y equals?
Negative 1 over 2.
Negative 1 over 2. So 0, negative 1 half, and 1.
That was easy.
All right, we good with 12? All right, this one is going to look different on the test than it does here, okay? The graphs were colorful, and you notice how it had all the overlaps? It was the best I could do because I was using Desmos to graph it. The one that we're using on the test generator graphs it, so it would only have the shading where they're both shaded. Does that make sense? So on this one, it would only shade that region, okay? All right, so I basically, if you look at the equations, aren't all the graphs exactly the same? The big difference is where it's solid and dashed and where the shading is, okay? So I need to kind of figure out which one is which. What's wrong?
Isn't
A and D, almost. The solid and the dashed are reversed. Okay, so that's where we're going to eliminate. So we're going to try to eliminate stuff, okay? So I need to figure out which line is which. Let's solve this line right here. So that's the line x less than or equal to y, isn't it? So if I was going to graph that, if I flipped that around, I keep the alligator open. Isn't that the line that is a y-intercept of 0 and the slope up 1 over 1? So it's this line right in here is that one, right? Should it be solid or dashed?
solid.
Solid. So does this one here work for it? No. So that one's gone. Are all the other ones okay? Yeah, so all the other ones are fine as far as the solid and dashed. The other line should be what? Dashed. Is the other line dashed in all the rest of them?
Yeah.
Yeah. All right, so what we would do from here is we would pick our test point. Okay, I don't almost need to solve it because I know I've got the right 3 down to the right 3. On this one on this first one is 0, 0 going to be okay?
No.
Yeah, because it's not going through 0, 0, right? On this line here, it's going through 0, 0. I can't use 0, 0. Okay?
Nope.
So let's use 0, 0 into this first one. I put 0 in for x and 0 in for y. True or false? False, right? Because I've got 0 greater than 9. And we'd rather have 9 cookies than 0 cookies, right? We'd rather eat 9 cookies. So that means I need to be shading away from 0, 0 on that line. So let's look at what we've got here. What can I eliminate based on that?
C.
It looks like this one here, right? Which I think was actually B in your graphic. Because I think I went down like this. A, B, C, D. Is what I think I did when I copied and pasted them. All right, so now we've got it down to these two. I've got to test in this one. I don't get to test 0, 0. I don't get to test 1, 1. I'd probably go ahead and go, what, negative 1, 0? That would work. Or 1, 0 would work. Okay. All right, so I'm putting in a -1 for the x and a 0 for the y. Is that true or false? I plugged it into here. False, right? No. True. We'd rather have 0 cookies than -1 cookie. So I want to go towards that point, -1, 1. So you tell me which one is correct. D is the correct graph. Sometimes it's almost harder to do those when they give you the pictures than it is when you just draw it yourself. And if all else fails, could you draw it yourself and then match your graph? Yeah, that might be your better shot to do. Okay?
Confused on everything what you just did.
Well, did you know how to draw the graph and match it? If you can do that, then do that. Okay? All right, let's look at 14. We have to find the partial fraction decomposition. So this was the newest stuff that we did, right?
Yeah.
All right. Shouldn't be that bad. We know we've got to split it into 2. There's none that are going to be split into 3. Okay, it'll only be 2. Yeah, I know. No, we don't even split into more than 2 in Calc BC. It only ever goes into 2. Okay? All right, so I need to do my good old magic X. I need 2 numbers that multiply to 3 and add to 4.
3 and 1.
3 and 1. So that means underneath here I have x plus 3 times x plus 1, which means one of these is x plus 3 and one is x plus 1, and I make one an A and one a B. Maybe. Okay. Honestly, does it really matter what letters you use up there? No. You can pick your favorite, other than an x, right? So x plus 3, x plus 1. I'm going to multiply everything by both of those terms. X plus 3, x plus 1, x plus 3, x plus 1. All right. So everything cancels here. I've got 2x minus 2. What cancels in this one here? X plus 3, and I'm going to distribute in the a. So I get ax plus what? A. What cancels in this term here? Good, and we're going to distribute in the b. What do you get? Plus 3b. All right, and then this is, if you want the colored pencils out tomorrow, you are more than welcome to the colored pencils. Okay, I think we did blue first, right? So I do an x equation, so you've got 2 equals a plus, I lost the x, didn't I? Plus b. So 2 equals a plus b. And then the red, we circled in red, -2a and 3b. So we'd say that -2 equals a plus 3b. All right, what would we use now? Do you want to use substitution, elimination, or Cramer's rule? Elimination. Are we going to eliminate the a or the b? A. So I'm going to multiply this first equation so I can just write it underneath. So -2 equals -a minus b. The 2's are gone, so I get 0. The a's are gone. What's 3b and... Thank you, it's -4. I'm not adding well today, am I? It is Monday, and it's raining too on top of it, right? We can use everything in the world for an excuse this morning, right? All right, what do I end up getting? -2. And then to solve for a, I'd probably go into this first one here, the blue one. So 2 equals a minus 2. So a equals what? 4. So your final answer, remember, you go from this guy here, you have to rewrite it as 4 over x plus 3 plus -2 over x plus 1. This one, I didn't put in a million different answer choices because it would just have been a nightmare. So if you didn't mark you right, remember Mrs. Ballard will go back and mark you right, or it'll be multiple choice, right? All right, let's try 15. So we're supposed to find the partial fraction again, okay? So we need to do some factoring here of this denominator. Let's do that over to the side here. So I need 2 numbers that multiply to -2 and add to 1.
-1 and 2.
All right, do we need a box?
Yes.
Why? Good, so we have to get out our box. So I've got 2x squared and -1 and 2x and -x. What times what is 2?
2 and 1.
Where's my 2 gotta go?
This side.
How many times does 2x divide 2x?
1.
How many times does x divide -x? Negative 1 times 1 is negative 1. So underneath here I have 2x minus 1 times x plus 1. We're going to split that into 2x minus 1 plus x plus 1 and a and b. All right, then we multiply everything by the least common denominator, right? 2x minus 1, x plus 1. 2x minus 1, x plus 1. All right, in the first thing, as planned, everything cancels, and I'm writing down 5 minus 1x. In the second one, what cancels?
2x minus 1.
Good, and we're going to distribute the a. What do we end up with?
Ax plus a1.
Good. All right, what cancels in the second one?
X plus 1.
And distribute the b. What do you get?
2bx
Good. All right, then I get out my blue colored pencil and I look at everything that's in front of an x. Notice it kind of went in reverse order there in the first term. So I have negative 1 equals a. I lost my b in my box, plus 2b. All right, and then we circled in red everything that was a constant. So it's looking like 5 equals a minus b. All right, substitution, elimination, or Kramer's rule?
elimination.
All right, do you want to eliminate the a or the b? The a. All right, so I'm going to multiply the first one by a negative. So I've got 1 equals negative a minus 2b. All right, 5 plus 1 is 6. The a's are gone. Negative b and negative 2b is?
Negative 3b.
Good, so b is equal to?
Negative 2.
Good. Do you want to substitute in the first one or the second one?
Second one.
I go with the red one, right? Because the coefficients are all 1. So 5 equals a minus negative 2. Not b, negative 2. Double negative goes positive. A equals 3. So then we rewrite it as 3 over 2x minus 1 plus negative 2 over x plus 1. All right, 2 more. And we've got it. All right. Ellie has a set of nickels and quarters. She has a total of 40 coins worth $5. Ellie is my daughter, by the way. Yeah. And she keeps her coins in a sock. I don't know why. She emptied her piggy bank the other day and put them all in a sock. She counted $7 so she could pay for her field trip. I wouldn't let her pay for it, though. All right. She has a total of 40 coins worth $5. She sets up a system of equations to model this situation. One of the equations, so they gave you one of the equations. Okay, so one of them is the nickel times x plus the quarter times y equals $5. Okay, what is the other equation? Write your answer in ax plus by equals c form, where a and b are whole numbers with no common factor other than 1. All right, so obviously they're saying the x is equal is representing what? Nickels, right? And the y is representing quarters, okay, according to what they've set up in the problem. They've already given me the money equation. All we need is the total equation, okay? So how would you write the total equation? X plus y equals 40. Because this has already taken care of the money, right? This one was your money. So all you had to do was write the second equation. Done. That one was pretty easy, wasn't it? It was. Okay, let's look at this last one here. This is the last one we're going to do together. Okay? On Saturday, the Anderson family had dinner at a restaurant. They ordered 2 pizzas and 4 cheeseburgers for $31.50. The following weekend, the Anderson family had dinner at the same restaurant where they ordered 3 pizzas and 2 cheeseburgers for $33.25. Which system of equations can be used to determine the cost of 1 pizza and 1 cheeseburger? First of all, looking at those equations, which 2 get eliminated right away?
A and B.
Are we doing anything with multiplication? C and D are gone because they're multiplying, right? So it's got to be one of the top two. All right. So let's look at the first equation. It should say 2 pizzas and 4 cheeseburgers for 31. So they did their cheeseburgers first. So 4 cheeseburgers, or maybe not.
Nope, they did it wrong.
They did it backwards. Plus 2 pizzas, right? Equals 31.50. It's looking like this one here, isn't it?
2C though.
Yeah, so is that the right one?
No.
Look at this one right here. Did they do it right?
Yeah.
Okay, let's double check the second equation to be sure. 3 pizzas, so 3 pizzas plus 2 cheeseburgers equals 33.25. Is this one correct now?
Yes.
Yeah. So yeah, some of them are going to be wrong, aren't they? That's the whole point. Okay. All right, that's where I'm going to stop. So tomorrow you need to make sure that you have your notes ready to turn in. How many more times do you need to do this study guide?
3.
2 to 3 more times, okay? Make sure you check, you put it away, put your answers away, and then come back out and check your answers as you're doing it, okay? And I will try to get the video up probably before lunchtime, okay? You guys can get stuff put away. I know we're at time almost.